Hey there everyone, Ramesh here, back again with another video. In this video I want to build the REST APIs for a simple banking application using Spring Boot, Spring Data JPA and MySQL database. Well, we are going to basically build the simple version of banking application. And we are going to use the latest version of Spring Boot and latest version of Spring Data JPA and latest version of MySQL database. Okay, so without further ado, let's get started. So just let us jump into the browser. So I'm in a Chrome browser and open the new tab over here and just type start.spring.io. This will brings up Spring Initializer, and here select the project Maven and choose the language Java, and let us keep the stable version of Spring Boot as of now, that is 3.2.1. so this is the latest and stable version of Spring Boot as of now. Next, go to the project metadata over here, and here let us give group as net.java guides, and let's give artifact as banking app. Next, project name is same as artifact, that is banking app. Next, description, let us give the description something like demo project for Spring Boot banking app. Next, let us give package name as net.javaguides.banking. Next, let us keep packaging as a jar, and let's keep Java version 17. Next, go to the dependency section over here, and here just search for web, and let us select this Spring Web Starter dependency. Well, we use this dependency to build the RESTful APIs, and this dependency internally provides Apache Tomcat server as a default embedded container. So let us select this dependency. Next, let us type Spring Data JPA. Well, we want to build the JPA repositories using Spring Data JPA. Well, this Spring Data JPA dependency internally provides latest version of Hibernate. Okay, so let us select Spring Data JPA over here. Next, type MySQL. So we want to use MySQL JDBC driver to connect our Spring Boot application with the MySQL database. Next, let us select the Lombok dependency. Well, we want to use Lombok dependency to reduce the boilerplate code such as getter setter methods, constructors, toString equals, and hash code methods. Okay, so let us select Lombok dependency over here. Alright, so as of now, these dependencies are enough for our Spring Boot application. Next, go ahead and click on generate button over here. So before that, you can also explore the Spring Boot application using explore option over here. So just click on explore, and here go to the pom.xml file, and you can see the Spring Boot version, Java version, and the dependencies as well. Okay, perfect. Next, click on close button and go ahead and click on this generate button to generate the Spring Boot application as a zip file. Okay, next go ahead and open this zip file in a folder. Perfect. Next, let us unzip this zip file. Alright, next let us open the IntelliJ IDEA. So here I have opened IntelliJ IDEA. Next, click on open option over here to open the existing project. In my case, the project is downloaded in a downloads folder. So let me go into the downloads folder over here, and next let me select the project. Let me click on open. Now we have successfully imported the Spring Boot application in IntelliJ IDEA. Next, let us go ahead and let us start developing this Spring Boot application. Next step is we will configure the MySQL database in our Spring Boot application so that our Spring Boot application can able to connect to the MySQL database. So go to the src folder and go to main folder, go to resources, go to application.properties file. So here inside application.properties file, we are going to configure the MySQL database details. Okay, so before configuring MySQL database details in the application.properties file, let us first create the database in a MySQL server. So in our case, we are going to use MySQL Workbench to interact with the MySQL server. So here, let me quickly create the new database. So here, let us write the SQL statement create database followed by the database name. So let us give database name as banking app. Next, let us select this, click on execute, and next refresh schemas. And here you can see banking app database is successfully created. Next, we can make this schema or database as a default, so that we can only focus on this database. Next, let's go back to IntelliJ IDEA over here and go to application.properties file, and here let us configure the MySQL database properties. So just type spring.datasource.url equal to JDBC and then MySQL and then localhost and then port 3306 and then followed by the database name banking_app. So this is the JDBC URL that our Spring Boot application will use to connect with the MySQL database, and here we are using localhost because our MySQL server is running in a local machine. That's why the host name is localhost, and this is the default port for a MySQL server, and this is the database name. Next, let us configure the MySQL database username and password. So here spring.datasource.username. In my case, the username is root. Next, let us configure the password. Spring.datasource.password. Well, in my case, this is the password, but make sure that whatever the database username and password that you have given while installing the MySQL database, that you have to provide over here. Next, let us tell Hibernate to automatically create the tables using JPA entities. For that, let's configure the property spring.jpa.hibernate.dtl-auto equal to update. Alright, so this property basically ensures that the Hibernate should create the database tables automatically based on the JPA entities that we will create in the Spring Boot application. Next, we no need to add Hibernate delete for a MySQL database because Spring Boot 3 internally uses Hibernate 6, and Hibernate 6 will automatically configure the Hibernate delete for a database based on the JDBC driver dependency that we add in the Spring Boot application. In our case, we have added MySQL JDBC driver, so Hibernate 6 will automatically configure the Hibernate delete for a MySQL database. Okay, perfect. Next, let us run the Spring Boot application so that we can make sure that our Spring Boot application can able to connect to this banking app database. So go to our main entry point class over here, and from here let us run the Spring Boot application, and here click on enable button to enable the Lombok annotations. And notice here there are no errors in a console logs. It means our Spring Boot application is successfully connected with the MySQL database. Next step is we will create a JPA entity. So before that, let's quickly create the packaging structure for our Spring Boot application. So right click on the base package, new, and then choose package. Let's give name as entity. Next, let's create one more package. Right click, new, and then choose package. Let's give package name as controller. Next, right click, new, and then choose package. Let's give package name as service. Next, let's create one more package. Let's call it as repository. Perfect. Next, go to entity package, right click on it, new, and then choose Java class. Let's give class name as account. Next, let us define the fields for this account class. Private long ID, and then private string. Let's give name as account holder name, and then private double balance. Well, to keep it simple, let us have these three fields for our account class. Next, let us make this class as a JPA entity by using JPA annotations. So let us annotate this class with add entity annotation to make this class as a JPA entity. Next, let us configure the table details by using add table annotation. So here let's use name attribute to give a name to the table. Let us say accounts. Perfect. Next, let us use Lombok annotations to automatically create a getter setter methods for this account class. So here let us use at getter lombo connotation, and next let us use at setter lombo connotation. Next let us also use the constructor related annotations, for example no argument constructor and all argument constructor annotation. Next let us use few more JPA annotations over here. So go to the ID field and let us annotate this ID field with at ID annotation to make this ID field as a primary key in a database. Next let us use at generated value annotation to configure primary key generation strategy. So this annotation has a strategy attribute, and let us give the generation type as an identity. So this will basically automatically increment the primary key. Next here let us use at column annotation to configure the column name for this field. So here let us use name attribute and let's give column name as account underscore holder underscore name. Okay, perfect. Now we have created account JP entity. Next let us run this Spring Boot application and let us see whether the Hibernate will automatically create a table for this account JP entity or not. Okay, so go to main entity point class over here. From here let us run the Spring Boot application, and notice here there are no errors in the console. Let's go to database and go to banking app database, refresh the schemas, go to tables, and there we go. Accounts table is created, and the columns like ID, account holder name and balance. It means the table is successfully created and the columns are also looks good. Okay, so let's go back to IntelliJ IDEA. Next step is let us create Spring Data JPA repository for this account entity. Okay, so go to a repository package, right click on it, new, and then choose Java class, choose interface, and here let us give the interface name as account repository. Perfect. Next let us extend this interface from JPA repository interface, and notice here JPA repository interface is a generic, so we have to pass two parameters. First is the entity name, in our case account. Second is the type of the primary key, in our case long. Okay, so if you go to account JPA entity, so we have given the long type to this ID field, right? So this long we are passing as a second parameter to this JPA repository interface. Okay, great. Well, once we create account repository interface that extends JPA repository interface, then this account repository will get a CRUD database methods to perform CRUD database operations on this account JPA entity. Alright, perfect. Next step is create add account REST API. So before creating the REST API, let us first create the service layer. Well, the controller layer is depends on service layer. So let us first create add account method in a service layer, and then we'll create the REST API, and that REST API will internally call the service method. So here go to service package, right click on it, new, and then choose Java class, and let us select interface, and let us give interface name as account service. Okay, next let us define the method over here. So let us say account and then create account, and let us pass account. Well, we can also use a DTO to transfer the data between client and server. Okay, so what we will do, we will use the DTO. So let's create a new package for it, and let's give package name as DTO, and here let us create a class and let us give class name as account DTO, and here let us type the field private long ID and then private string account holder name, and then private string, let us go double, and then balance. Alright, and here let us use at data lombo connotation to automatically generate constructors, getter, setter methods. Next, let's go back to account service interface, and here instead of account JPA entity, let us use account DTO. So here also let us pass account DTO. Okay, perfect, and let's view the name as account DTO, and let's remove this unused import. Okay, perfect. Next, go to service package and let's create one new package and let's call it as IMPL. IMPL stands for implementation, so all the implementation classes we keep under this IMPL package. So right click on this package, new, and then choose Java class. Let's give class name as account service IMPL. So this is the naming convention. Next, this class implements account service interface and implement its methods. So here just mouse on this class, click on this implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us annotate this class with add service annotation to automatically create a Spring Bean for this class. Next, let us inject the dependency. So here, let us first declare the field private account repository. Next, let us use a constructor based dependency injection to inject this account repository dependency. So here right click and then generate and then constructor and select the dependency, click on OK. Alright, next here we can annotate this constructor with @attribute annotation to automatically inject the dependency, but Spring 4.3 onwards we can ignore this @attribute annotation, because whenever Spring will find the single constructor in a Spring Bean, then Spring will automatically inject the dependency. Okay, perfect. Next, go to create account method over here, and within this method we need to convert account DTO into account JPA entity, and then we'll save that account JPA entity into a database. So this is the conversion logic, right? So let us create one mapper class and let us write the common logic, like we can convert a DTO into JPA entity and JPA entity into DTO. So here go to DTO package, or else let's create one more package and let's call it as mapper. Next, within a mapper package, let's create a new class. Let's call it as account mapper. So within account mapper class, let's create static method public static, and let us give the return type account, and let us give method name as map to account, and let us pass account DTO as a parameter. Perfect. Next, let us convert this account DTO into account. So here let us create the object account and then account equal to new account. Next, let us pass the details to the constructor account DTO.getID and then account DTO.get account holder name and then account DTO.get balance, and then finally return the account object. Now we have converted account DTO into account JPA entity. Similarly, let us write one more static method to convert account JPA entity into account DTO. So here just type public and then static and then return type as account DTO. Let's give method name as map to account DTO, and let us pass account JPA entity. Perfect. Next, let us create account DTO object over here. Alright, and let us pass values to the constructor like account dot get ID and then account dot get account holder name and then account dot get balance, and then finally return this account DTO. Well, let us see what is the compilation error over here. It says the parameterized constructor is not available in the account DTO. So go to account DTO over here. So this add data annotation don't provide the constructor. So here let us use add argument constructor annotation. Okay, let's go back to mapper class, and there we go. Alright, now we have created a mapper class to map DTO into entity and vice versa. Next, let us use this account mapper class in a service classes. So go to account service IMPL class over here and go to create account method, and here let's create object of account and then account, and then let us call account mapper over here, account mapper, and then it has map to account method, and then pass account DTO. Next, let us call account repository over here, and then it has a save method. So let us call save method to save the account JPA entity, and then pass account JPA entity object to this save method. So this save method basically return the saved entity. So here let us introduce a local variable of type account, and let's give variable name as saved account. Okay, perfect. And if you look at the create account method return type account DTO. So let us convert saved account into account DTO. So here let us remove this null and then call account mapper and then map to account DTO and then pass saved account. Okay, perfect. Now we have created a create account method. It will call the account repository to save the account into the database. Next, let us create the REST API, and then that REST API will internally call this method. So go to controller package over here, right click on it, new, and then choose Java class. Let us give class name as account controller. Let us annotate this account controller class with @REST controller annotation. So this @REST controller annotation will make this class as a Spring MVC REST controller class. Next, let us annotate this class with @request mapping annotation, and let us pass the base URL over here. Let us say /API/accounts. Okay, so this is basically a base URL for all the REST APIs that we are going to define within this account controller class. Okay, great. Next, let us inject the dependency. For that, let us first define the field, that is private account service. Next, let us use a constructor based dependency injection to inject this account service dependency. So here right click, generate, and then constructor, and then click on OK. Now we have injected account service using constructor based dependency injection, and here again we don't have to use @word annotation because this class has only one constructor, so Spring will automatically inject the dependency. Next, here let's create a add account REST API. Well, creating a REST API using Spring Boot is very simple. First we need to create a method, and then we'll make that method as a REST API by using Spring annotation. Okay, alright, so just type public, and then let us use response entity as a return type, and this is generic, so we can pass account DTO as a type. Let's give method name as add account, and then pass account DTO as a parameter to this method. Alright, perfect. Next, let us have a return statement over here. Return new response entity, and then call account service dot create account, and then pass account DTO. Next, let us pass the HTTP status, that is created. HTTP status created. Perfect. Now we have created add account method. It will call account service dot create account method, and this create account method basically return the saved account. So this is the first argument. Second argument is HTTP status. Okay, perfect. Next, let us make this method as a REST API by using Spring annotation. So in this case, this method have to handle the HTTP post request. For that, let us use @post mapping annotation. Next, here let us use one more annotation, that is @request body annotation. So this @request body annotation will map the request body to this Java object. So request body basically contains JSON, so this @request body will automatically convert that JSON into this Java object. Okay, perfect. Next, let us go ahead and let us run our Spring Boot application, and let us test this add account REST API. So from here, I am going to stop the running application first, and I am going to run the application again. And notice here our Spring Boot application is up and running in a embedded Tomcat server on port 8080. Next, let us open the Postman REST client. and here let's create one new request, and here let us choose HTTP post method and just type the request URL HTTP localhost 8080/API/accounts. Okay, so if you go to project again and if you go to account controller, the URL is /API/accounts. So this is the URL we are using over here, /API/accounts. Okay, next go to body and then select raw, select content type as a JSON, and here we need to pass the JSON in the request body. So let us quickly create the JSON object. So if you go to project again and if you go to account DTO, so this account DTO has field account holder name and balance. So these fields we have to use in a JSON. So let me copy this field name and let me paste it over here, and then let's give holder name, in my case Ramesh. Next balance, let us say 10,000. Okay, next go ahead and click on send button, and there we go, we got the response from the server. And if you look at the ID here 1, so this ID we are getting from the database, and look at the status 201 created. Let us verify in the database. So go to MySQL Workbench, go to accounts table, select rows, and you can see the account is successfully stored in a accounts table. Okay, perfect. Now we have successfully built add account REST API. Next let us build get account REST API. So let's go back to our IntelliJ idea. So here let's first change the service layer. So go to account service interface and let us define the method. So here let's give method name as account DTO. Let's give method name as get account by ID, and then pass ID as a parameter. Perfect. Now we have defined get account by ID method in a account service interface. Next let us implement this method in a account service IMPL class. So go to account service IMPL class over here, just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Next let us implement this get account by ID method over here. So here just call account repository, it has find by ID method, and notice here find by ID method returns optional of type account. Okay, so just call find by ID and then pass ID over here, and then call or else throw method over here. Well, let us say the account with a given ID is not existing in database, then we have to throw the exception. For that we can use or else throw method over here. So just call this or else throw method, and then here let us pass the lambda expression implementation. Well, this or else method takes supplier functional interface, and we have to provide the lambda expression implementation for this supplier functional interface. So here is the lambda expression to create a new exception and throw that exception. New, let us throw the runtime exception over here. You can create your own custom exception and you can throw that exception from here. So let us say account does not exist. Okay, perfect. Next here let us take the return return value from this method. Let us say account. Next this get account by ID method returns account DTO. So let us convert this account JPA entity object into account DTO. For that let us call account mapper, and then it has map to account DTO and then pass account. Perfect. And here let me align this properly. Perfect. Now we have created get account by ID method in a account service IMPL class. Next let us create get account REST API that will internally call this method. So go to controller layer and go to account controller class, and here let's create get account REST API. So here let me first write the comment get account REST API. Let us type the method public and then response entity, and then pass account DTO as a type. Let's give method name as account get account by ID, and then pass ID as a parameter to this method. Next, let's call account DTO and then call account service dot get account by ID and then pass ID. Perfect. Next, let us have a return statement, return and then response entity dot OK and then pass account DTO in a body. Perfect. Now we have created a get account by ID method. So let's refactor this. Now we have created get account by ID method. It returns the account object, and look at the OK method. So this OK method internally returns the HTTP status 200 OK. Alright, perfect. Next, let us make this method as a REST API by using Spring annotations. So this method have to handle HTTP GET request. For that, let us use add get mapping annotation. Okay. So this add get mapping annotation will map the incoming HTTP GET request to this particular method. Next, let us pass ID to this annotation. Within a double quote slash within a curly braces, just pass ID. So this ID is nothing but a template, variable. Next, we need to bind the value from this template path variable to this method argument. For that, we can use add path variable annotation over here. Alright, perfect. Now we have built get account REST API. Next, let us rerun our Spring Boot application and let us test this get account REST API. So from here, let us stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's head over to the Postman client over here, and here let's create a new request. Let us enter the URL http :localhost 8080/API/accounts and then pass account ID 1. Next, click on send button, and there we go. We got the response from the server. And look at here the ID 1, account holder name Ramesh, balance 10,000 and the HTTP status 200 OK. Now we have developed a get account REST API. Next, let us build deposit REST API. Well, basically we are going to develop the REST API that will deposit amount into a account holder name. For example, here the account holder is Ramesh. He has a balance 10,000. Next, we are going to deposit some amount into this, Ramesh account holder. Alright, so basically we are going to add some amount to the existing balance. Okay, it's pretty simple. So let us go to IntelliJ IDEA over here and let us first develop the service layer. So go to account service interface, and here let's give account DTO as a return type. Let's give method name as deposit, and let's pass first parameter as ID. Next, let us pass second parameter as a amount that we want to deposit into account. Now we have defined deposit method in account service interface. Next, let us provide the implementation for this deposit method in a account service sample class. So let us jump into account service sample class. Mouse over on this class, click on implement methods over here, and then click on OK. Next, let us implement this deposit method. Well, within a deposit method, first we'll check whether the account with a given ID exists in a database or not. If the account with a given ID is not exist in database, then we'll throw the runtime exception, right? So here we have already written a piece of code. So let me copy this piece of code and let me paste in a deposit method. Now we got the account for this particular account ID. Next, let us call its get balance method and then add this amount to existing balance. Okay. Next, here let us introduce a local variable double, and let's call it as total equal to. Perfect. Next, let us call account and then let's call it set balance method and then pass total. Okay, perfect. Next, we need to save this object into a database. For that, let us call account repository and then call save method and then pass account object. Perfect. Next, this save method returns saved account object. So here let us introduce a local variable account and then saved account. Next, this deposit method returns account DTO. So let us convert this account JPA entity into account DTO. So here let us remove this null and then call account mapper. It has map to account DTO and then pass saved account. Okay, perfect. Now we have implemented deposit method. It will deposit an amount into an account, and the logic is pretty simple. We will get the existing balance from the account and we'll add the amount to the balance, and then we'll get the total amount, and then we'll add that total amount as a balance to the account, and then we'll save that account into a database. Okay, it's pretty simple. Next, let us build the deposit REST API that will internally call this method. So go to account controller and here deposit REST API. Alright, so here let's type public. Let's give return type as a response entity, and here let's give the type as account DTO, and let's give method name as deposit, and then let us pass two parameters to this method, long ID, and then second parameter as map. It takes key as a string, value as type double. So basically we'll pass amount in a request body. For that we'll use a map. Okay, next let us call it as request. Perfect. Next, within this deposit method, let us call account service. It has deposit method, and then let's pass ID as a first parameter. Second parameter we need to pass the amount, so we can get that amount from the request object. So here request dot get, and then we can pass key as a amount. Okay, next let us introduce a local variable amount account DTO. Okay, next let us have a return statement, return response entity dot OK, and then pass account DTO in a body. Now we have created a deposit method, and then internally we'll call account service dot deposit method, and then we'll pass ID and then amount. So we can extract this as a separate variable as well. So here what we'll do, we'll store in a local variable, let us say double, and then amount equal to request dot get, and then pass this amount over here. Okay, so this will basically improve the readability. Next, let us annotate this deposit method with @put mapping annotation. Well, we use @put mapping annotation to map incoming HTTP put request to this method. Next, within a double quote slash, and then pass ID. Next, slash deposit. So this is the URL for this REST API. Next, let us store the value of this ID into a method argument using @path variable annotation. So here let us use @path variable annotation to bind value of this template URI variable to this method argument. Next, here let us use one more annotation, that is @request body annotation. Well, this @request body annotation will map the request JSON body into this map Java object. Okay, perfect. Now we have developed a deposit REST API. Next, let us go ahead and let us rerun our Spring Boot application, and let us test this deposit REST API. So here let me stop and rerun the Spring Boot application. Alright, our Spring Boot application is up and running. Next, let us head over to the Postman client over here, and here let's create a new request, and here let us choose HTTP put method, and here let us enter the request URL. So let me copy this and let me paste it over here. Next, let's go to body and then choose raw, and then choose content type JSON, and here let us pass the JSON and the key as amount and the value. Let us say we want to deposit 5,000. Okay, That's it. Next, click on send button. So this says method not allowed. Well, here we need to give the correct URL. So let's go to IntelliJ IDEA and let's see the URL that we have given to the REST API. We have given the URL id/deposit. So we need to append this deposit in the URL as well. So here's /1/deposit and then click on send button, and there we go. In a response you can see the JSON account 1, account holder name Ramesh, and the balance is 15,000. Earlier it was 10,000. Now you can see the balance 15,000. Okay, it means we have successfully deposited 5,000 into account Ramesh. Next, let us say we want to deposit 10,000. Next, click on send button and you can see the response, the total balance 25,000. It means the deposit REST API is working as expected. Next, you can see the same change in the database table as well. So go to accounts table, right click, select rows, and you can see the balance 25,000. Okay, it means we have successfully built deposit REST API. Okay, great. Next, let us build withdraw REST API. So let us go to IntelliJ IDEA and let's create the withdraw REST API. So let us first change the service layer and then we'll change the controller layer. So go to account service interface and here let's define the method. Let's give return type as account DTO. Let's give method name as withdraw and let's pass parameter as long ID. Let's also pass the second parameter, that is amount. Perfect. Now we have defined withdraw method in a account service interface. Next, let us provide the implementation for this method in a account service sample class. So let us jump into account service sample class. Just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us implement this withdraw method over here. So here, first we'll check whether the account with a given ID is exist in a database or not. If the account with a given ID is not exist in database, then we'll throw the exceptions like account does not exist. Okay, so that piece of code we have already written in a existing methods. So we can copy that piece of code from here. So go to deposit method and copy this piece of code. Okay, and again go to withdraw method and here simply paste it. Okay, perfect. Next, let us add one more condition, like if the withdraw amount is greater than the balance, then we'll throw the exception like insufficient amount. Okay, so here let's add the if condition and then account dot get balance. So if the account balance is less than the withdraw amount, then we'll throw the runtime exception. So here throw new runtime exception and let us pass the message insufficient amount. Perfect. Next, here let us write the logic double total equal to, so here just call account dot get balance minus amount. So in this case we are withdrawing the amount from the balance, that's why we are using a subtraction. Okay, next let's call account dot set balance and then pass total. Okay, perfect. Next, let us call account repository and then call save method and then pass this account object. Next, this save method returns the account, saved account object. So let us introduce a local variable of type account. Let's call it as saved account. Perfect. Next, if you can look at the withdraw method over here, it returns the account DTO. So let us convert account entity into account DTO. So here let us remove this null and let's call account mapper, and then it has map to account DTO and then pass saved account. Okay, perfect. Now we have implemented withdraw method. Internally it will call account repository dot find by ID method Let us say if the account with a given ID is not existing in database, then we will throw the runtime exception. Next, we have added one more condition, like if the withdraw amount is greater than the balance, then we will throw the runtime exception like insufficient amount. Next, let us say the balance is greater than the withdraw amount, then we will write the logic like we will withdraw some amount from the existing account balance, and then we'll add that total to the account, and then we'll save that account into a database, and then we'll return the updated information. Okay, the logic is pretty simple. Next, let us build the withdraw REST API that will internally call this method. So go to account controller. So here let me first write the comment withdraw REST API. So just type public and then response entity, and then pass account DTO. Let's give method name as withdraw, and then pass two parameters. First parameter as ID, second parameter as a map. The key type is string, the value type is double, and let's call it as request. Perfect. Next, let us get the amount from the request. So here double, and then amount equal to request dot get, and then pass amount. Alright. Next, account DTO equal to account service dot withdraw, and then pass ID and then amount. Next, let us have a return statement, return response entity dot OK, and then pass account DTO in a body. Perfect. Now we have created withdraw method. It will internally call account service dot withdraw method, and it will pass account ID and the withdraw amount. Okay, next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add put mapping annotation. Well, this put mapping annotation will map incoming HTTP put request to this method, and then let us pass the ID and then withdraw. Perfect. Next, let us bind the value of this ID to this method argument by using at path variable annotation. Next, let us use one more annotation, that is at request body annotation. Now we have built withdraw REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, let us stop and run the Spring Boot application. Alright, our Spring Boot application is up and running. Let's go to Postman client over here, and here let's create a new request. So let me copy the request URL from the existing REST API request. So here let us select HTTP put method and then pass request URL localhost 8080/API/accounts/the account ID, and then withdraw. Alright, so here we are going to basically withdraw some amount from the account with ID 1. Next, let us go to body, select raw, choose content type JSON, and here let us pass the withdraw amount. Let us say I want to withdraw 5,000. Next, click on send button, and there we go. In a response, you can see the account holder name and the balance. Earlier the balance was 25,000. Now you can see the balance 20,000 because we have withdrawn the amount 5,000. Okay, next let us say I want to withdraw 5,000 more. Then what I can do is I can click on send button, and you can see the response, the balance is 15,000. Next, let us say I want to withdraw 10,000. Then the balance should be 5,000, right? So let's click on send button, and you can see the balance 5,000. It means the withdraw REST API is working as expected. Next, let us build get all accounts REST API. Well, first we'll change the service layer, and then we'll change the controller layer, because controller layer depends on service layer. So let us head over to account service interface over here, and within this interface let us declare a method. So let's give the method return type as list. List is a generic, so let us pass account DTO as a type. Let's give method name as get all accounts. Perfect. Next, let us go and let's implement this method in a account service IMPL class. So let us jump into account service IMPL class over here. Just mouse over on this class, and here you will get a link to implement the methods. Click on this implement methods, select the method that you want to implement, and click on OK. Next, let us write the logic to implement get all accounts method over here. So within a get all accounts method, let us call account repository. It has find all method, and notice here find all method returns a list of account. So just call this find all method over here. Next, let us get the result of this find all method in a list. So list and then account. Let's call it as accounts. Okay, now we got a list of accounts. Next, let us convert this list of account into list of account DTO. So here let us call accounts. So accounts is a list, and list has a stream method. So here just call stream method, and the stream has a map method. So let us use map method to map entity into DTO. And look at here, map method takes function as a functional interface. We need to provide the lambda expression implementation of this function functional interface. So let us call this map method over here, and let us pass the lambda expression implementation. Well, here let us pass account entity object as a parameter to the lambda expression, and then this is the lambda symbol, and then call account mapper. It has map to account DTO method, right? And then pass account entity object. Next, let us call collect collectors dot toList method. Okay, perfect. Well, here we are using account mapper dot map to account DTO method to map account entity object into account DTO. And finally, we are returning the list from the stream, and this list basically contains the list of account DTO. Okay, so here let us have a return statement and remove this return null. Okay, now we have implemented get all accounts method. It will return the list of account DTOs. Next, let us create get all accounts REST API that will internally call this method. So let us head over to account controller over here, and here let me write the comment get all accounts REST API. Perfect. So here let us first create the method, and then we will make that method into REST API. So just type public and then response entity. Response entity is a generic. Let us pass type as a list, and again list is a generic. So let us pass account DTO as a type. Let's give method name as get all accounts. Okay, next within this method let us call account service and then call get all accounts method. So this get all accounts method return list of account DTO. So here let us have list and then account DTO. Let's call it as accounts. Perfect. Next, let us have return statement and then response entity. It has OK method and then pass accounts in a body. Perfect. Now we have created a method called get all accounts. It returns a list of account DTOs. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Okay, that's it. Next, let us go and let us rerun our Spring Boot application and let us test this get all accounts REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us head over to the Postman client over here and let's create a new request and let us choose HTTP get method over here and let us enter the request URL. Well, let us copy from the previous REST API and just paste it over here, and here let us remove these parameters and just keep localhost 8080/API/accounts. Next, go ahead and click on send button, and there we go. In a response you can see a list of accounts. So So as of now there is only one account. Now what we'll do, we'll add a few more accounts. Okay, so go to the add account REST API over here, and here go to the body and just change the account holder name from Ramesh to John, and then balance, let us have 20,000. Click on send button. Now the John account is created. Next, let's create one more account. Let us say Sanjay, and then let's say balance 30,000. Click on send button, and there we go, Sanjay account is created. Next, let's go to get all accounts REST API, and next send the request, and there we go. In a response you can see a list of accounts, and there are total 3 accounts in the list. Alright, it means the get all accounts REST API is working as expected. Alright, great. Next, let us go ahead and let us build delete account REST API. Well, first we'll change the service layer, and then we'll change the controller layer. So go to account service interface over here, and here let's define the method. So let's give return type of the method as a void, and let's give a method name as delete account, and then pass account ID as a parameter. Now we have defined delete account method in account service interface. Next, let us implement this method in account service IMPL class. So let us jump into account service IMPL class over here, and just mouse over on this class, click on implement methods, select the method, click on OK. Alright, next let us implement this delete account method over here. Well, first we'll add the condition like if the account is not exist for a given ID, then we'll throw the runtime exception. Okay, so that logic we have already written in a withdraw method and deposit method and get account by ID method, right? So let us copy this piece of code from the get account by ID method, and then let's go back to delete account method over here, and within this method let us paste this logic. So here basically we are adding the condition like if the account with a given ID does not exist in database, then we will simply throw the runtime exception like this. Okay, great. If the account with a given ID exists in database, then we'll delete that account. So for that, let's call the account repository. It has a delete by ID method, and then pass account ID. All right, perfect. So this delete by ID method returns a void, so we no need to return anything. Now we have implemented delete account method. It will delete an account by given ID. Next, let us build the delete account REST API that will internally call this delete account method. So let's go to account controller over here, and here let's write the comment first, delete account REST API. Just type the method public, and then response entity, let us pass string as a type. Let's give method name as delete account, and then pass account ID. Perfect. Next, within delete account method, let us call account service. It has delete account method, and then pass account ID. So this will basically delete the account by ID. Next, let us have a return statement, return response entity dot OK, and then pass the success message here. Let us say account is deleted successfully, something like that. Perfect. Now we have created delete account method. It will delete the account by using account service dot delete account method and return the success message. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @delete mapping annotation. Well, we use @delete mapping annotation to map incoming HTTP delete request to this particular method. Next, let us pass the URI template variable over here. So here braces within a double quote slash within a curly braces ID. So this ID is nothing but a UI template variable, and this ID basically contains the account ID. So we need to bind the value of this ID into the method argument. For that, let us use @path variable annotation. Okay, perfect. Now we have implemented delete account REST API. Next, let us rerun our Spring Boot application and let us test this delete account JPA. So from here, I'm going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running. Next, let us head over to the Postman client and here let's create a new request. Let us choose HTTP delete method over here and here let us enter the request URL. So let me copy this and let me paste it over here, localhost 8080/API/accounts. So let us say we want to delete the account with ID 1. So just pass ID 1 in the URL. Next, click on the send button over here and there we go. You can see the response, account is deleted successfully with HTTP status 200 OK. Next, let us verify in the database. So let's go to MySQL workbench over here and go to accounts table, select rows and notice here the account with ID 1 is deleted from the accounts table. Next, let us delete the account with ID 2 as well. So let's go to Postman client and here let us pass the account ID 2 in the URL and click on send button and there we go, we got the success message. Next, let's verify in the database. So here let us refresh the table, that is select rows from the table and there we go, the account with ID 2 is successfully deleted. It means the delete account REST API is working as expected. Alright, great.